Hello. Hello. So today I'm discussing about the operating system basic memory management topic. So memory management is very important for functionally and storing our data. So how we are managing our memory in correct way. So memory management is the functionality of an operating system which handles or manage primary memory and moves process back and forth between main memory and disk during execution. Whenever we are executing the program, so that time we have need to store the data in the memory. So that time we are using memory management system. Memory management keeps track of each and every memory location regardless of either it is allocated to some process or it is free. It check how much memory is to be allocated to the process. If we are storing data, so how much we have to process the data, how much we need to memory in management. So that is the depend on the in one particular program who is storing and taking the space inside the memory. It decide which process will get memory at what time, which process is doing and which we are running. So that is the possibility when which program will take how much memory and where it will take inside the memory. It track whenever some memory gets freed or unlocated, and correspondingly it updates the status. Like whenever your execution is doing, so it will track and freed whenever you are just using any and executing any program, and in that some members and some variables taking the memory inside that space inside the memory. So that is the thing, like after the work, like they done their work, so we have to finish and we have to free the memory for another function. So that is the memory allocation. There is a management techniques, that is a contiguous and non-contiguous. So in contiguous technique, executing process must be loaded entirely in main memory. So in contiguous memory allocation, each process is continued in a single contiguous block of memory. So memory is divided into several fixed size partitions. Each partition contains exactly one process. Contiguous technique can be divided into two parts. First is a fixed or static partition. Second is a variable or dynamic partition. Fixed partition. This is the oldest and simplest technique used to put more than one process in the main memory. So this is partitioning. Number of partitions non-overlapping in RAM are fixed, but size of each partition may or may not be same. As it is contiguous location, so hence no spanning is allowed. So here partitions are made before execution or during system configuration. So there is a block size is 4 MB, and we have block of 16 MB to 14 size. So internal fragment is generally decide like how much part free in your memory. So free is 3 MB, like we have to add block sizes, we have to 4. So free memory is 3 MB, and I put this PN is 1 MB. Like we have free space is 3 MB, and after that when we stored one member inside that block, that is P1 equal to 1 MB. Second block is 8 size. So P2, suppose we generally stored 7 MB, and P3 stored 7 MB. So block is 16 MB. So P4 equal to 14 MB. So this is the fixed size, it is given to the fixed size. We can't extend it and we can't shrink it. Okay, so that is the fixed memory. In dynamic size, like in a fixed size means like your if you are doing programming languages like int, float, character, and you are using. So that is the predefined data types. So you can't change the size of that during the execution. They will definitely take same memory as they have memory size. So like if my int is at 2 bytes, so definitely it will take the 2 bytes in the memory. You can't grow it and can't shrink. So that is the fixed size that we can't grow and shrink. But in case whenever we talking about the data structure, so there is a we are using some data structure format, so we can grow and shrink. That is a linked list. It's a really important concept about the linked list because linked list is sufficient whenever we are using the linked list to grow and shrink the memory during execution time whenever we need and whenever we have to need some more data inside that. So this is the fixed size. Second is advantages of the fixed partitions. Easy to implement, easy to implement. It's contiguous memory, so it will take less, little less overhead. Okay, because we do not have too much thing to store inside that, so definitely it will be easy for us. Disadvantages of fixed partitioning means internal fragmentation, internal external fragmentation, limit process size and limitation of degree of multi-programming. Okay, variable partitioning. Variable partitioning means it is the contiguous allocation technique. Like it is used to alleviate the problem faced by fixed partitioning. Like in contrast with fixed partitioning, partitions are not made before the execution or during system configuration. Various features associated with variable partitioning, like initially RAM is empty, so and partitions are made during the runtime according to the process. So a process need instead of partitioning during the system configuration. The size of partitioning will be equal to incoming process. Like whenever we are executing any program, so that is the runtime memory dynamic structure. Whenever we are executing any program, so it will take the memory during the execution time, and we have to need some add some more data inside that. So during the runtime, we can increase the size of memory and also we can decrease according our need. So this is the beneficial for us. Third is saying like the partition size varies according to the need of process, so that the internal fragment can be avoided to ensure efficient utilization of RAM. Internal fragment means we have sufficient amount of data and during the runtime, so we have to need only 10 members inside that. So and we initialize a lot of memory for that. So in that case, we have can shrink that memory and utilize that memory. Sometimes we initialize large memory and stored less data. So space is there, enough space is also there because we store only less data as we declare the size of the memory. So in that case, that memory is wasted. We are wasting that memory space. So in that case, your variable partitioning is dynamic. It is saving your memory according your need. Fourth, number of partitions in RAM is not fixed and depends on the number of incoming process and main memory size. Means fixed size is taking the fixed data. Was taking fixed data because there is a int, float, and char. It's a fixed size of the memory. So that will taking the fix. But in memory and dynamic structure, they are not taking the fix because whenever we are executing it, so during runtime it will decide like how much data is taking, how much space it was taking. So how much taking the same execution and same space it will provide to that particular variable operating that like block size is 2 MB, so I'm just selecting is a 2 MB fixed size. But in previous case what was that that was fixed type, so there is not any limitation. We declared already the memory size, but we are storing only less data there, so that is wasting of memory. Second is a block size is 7 MB, third is 1 MB, and fourth is 5th MB. So empty space of RAM. So partition size, process size, so no internal fragment. Advantages of variable partitioning. no internal fragments and fragmentation, and no restriction on degree of multiprogramming, no limitation on size of the process, means how much size we can grow and shrink the memory according need. Disadvantages of partitioning, like difficult implementation. Why? Because it's not the like stuff, because we are adding more and more data, so it will be difficult to us to manage a lot of data, and sometimes it may be overloaded to memory to handle the all the data, because this is the dynamic, we can grow more and more memory according to our need. External fragment is like we are storing more and more data, so it was taking and it was extending the memory according our need. Free space memory management techniques in operating system. So the system keep tracks of the free disk block for allocating space to files when they are created. Also to reuse the space released from deleting the files. Free space management becomes crucial. The system maintains a free space list which keeps track of the disk blocks that are not allocated to some files or dictionary. The free space list can be implemented mainly as bitmap or bit vector. Bitmap or bit vector is series or allocation of bits where each bit corresponds to a disk block. The bit can take two values, 0 and 1. 0 indicate that the block is allocated and 1 indicate the free of the block. The given instance of disk block on the disk is figure 1 is showing in front of you. Where green block are allocated can be represented by bit of 1600, that is the 16 bit. This is so block 1 to block 16, because there is a 16 bit, so we initialize this block 1 to block 15. So here is a mark, that is some blocks are darker, you can see here, so that is the green block. Okay, and green block is allocated like block 1, block 2, block 3, block 4. 1 means there is a free, means block 5, block 6, block 7 is a free. Block 8, block 9, 10, 11, 12 and 13 are not free, because 0 means not free and 1 means free. This is the structure. Linked list. This approach for the free disk blocks are linked together. Free block contains a pointer to next free block. The block number of very first disk block is stored at the separate location on disk, and it's also cached in memory. So I can give you some example if you know about the linked list. So linked list first node data where is stored in head. So head is the first data locator storing the address of the first node, and first node containing the linked data part where is storing the second data node address. So it is continue till null. So last element it will be think like containing the null pointer, because there is a no further nodes. So that is the thing here, same as this, which is the free, like 5 6 7, because it's 1, so it's free, so that is containing the address of the first linked list, that is your head node. So whenever we are using and increasing the size of the memory, so in that case we can store the data inside the head. Okay, so now it's saying figure 2, the free space list had point to the block 5, so which point to block 6, and the next free block, and so on. So the last free block would contain a null pointer indicating the end of the free list. The drawback of this method is the input output required for free space list travels. Virtual memory. Virtual memory is very important according to the operating system, and it's really essential to understand it, and some basic type of questions also on this point, like you can easily anybody just ask about this, what is the virtual memory. This is the secondary memory for storing your part. So virtual memory is a storage allocation scheme in which secondary memory can be addressed as though it were part of the main memory. The address program may use to reference memory are distinguished from the addresses the memory system uses to identify physical storage sites, and program generated addresses are translated automatically to the corresponding machine addresses. The size of virtual storage is limited by addressing scheme of the computer system and amount of secondary memory is available, not by the actual number of the main storage locations. It is a technique that is implemented using both hardware and software. It maps memory addresses used by a program, called virtual addresses, into physical addresses in computer memory. So all memory references within a process are logical addresses that are dynamically translated into physical addresses at runtime. This means that the process can be swapped in one and out main memory such that it occupies different places in main memory at different times during the course of execution. The process may be broken into number of pieces, and these pieces need not be continuously located in the main memory during execution. So the combination of dynamic runtime addresses, translation and use of page or segment table permitted this. So how we are using the virtual memory, because we generally questioned about this, like if virtual memory we are using, so what is the think about it, like what is the backend process. So there is some page, like we not about it, like we in a copy have a page and we are writing something in on it by. So there is also page and segment inside the memory, because it's also storing and writing your data inside that so that you can utilize again and again. So that is the three. If these characteristics are present, then it is not necessary that all the pages or segments are present in the main memory during execution. This means that the required pages need to be loaded into memory whenever required. Virtual memory is implemented using demand paging or demand segmentation. So there is a two-way in which virtual memory is handled: paging and segmentation. It's important. Paging and segmentation is very important, very important. And I'm telling you, this is the concept where we have to be understand how the virtual memory part is going on. Paging first. Paging is memory management scheme that eliminate the need for continuous location of physical memory. So this scheme permits the physical address space of a process to be non-contiguous. Paging is a fixed size partitioning space, like a scheme. In paging, secondary memory and main memory are divided into equal fixed size partitions. Okay, this is the main memory, this is the second memory, as you can see. So main memory is like your frame containing, and secondary memory is your pages. So virtual memory, what is virtual memory? We think like that is your secondary memory, so it has some pages. And main memory we are using, that is a RAM, and it has some frame. So paging is a fixed size, so the partition of the secondary memories are called the pages, and the partition of main memory are called the frames. Okay, so each process is divided into parts where size of each part is same as page size. Okay, the size of last part may be less than the page size. The page of process are stored in the frame of main memory depending upon their availability. So address generated by CPU is divided into page number and page offset. So what is the page number? We denoting to the P. So numbers of bit required to represent the page in logical address space for page number, like 0, 1, 2, 3, like which type of we are generally storing the data. Page offset means number of bits required to represent particular word in a page, or page size of logical address space for word number of page or page offsets. So page number is like represent the logical address of a space, and page offset is that is your some words logical address space or number of words that define your page offset. Physical address divided into two. First is address generated by CPU, second is physical address, frame and frame offset. Okay, so frame number is like your number of bits required to represent the frame of physical address space of frame number. Physical address means your main memory. Okay, frame offset means number of bits required to represent particular word in a frame, or frame size of physical address space or word number of frame, or frame offset. The hardware implementation of page table can be done by using dedicated registers, but the usage of register for the page table is satisfactory only if page table is small. Okay, if page table contain large number of entries, then we use TLB, means translation look aside buffer, a especially small fast look up hardware cache. So the translation look aside buffer is associative high speed memory. So each entry is TLB consists of two parts, tag and value. When this memory is used, when an item is compared with all tags simultaneously. Okay, so if the item is found, then corresponding value is returned. This is the conceptual thing we have to understand. Okay, but it's more efficient whenever we are drawing diagram and just understanding what is happening. The CPU generally for taking two, page number and page offset. This is thing. Page number is your logical bits number, that's defined, and page word, that is giving the word number of your space of your memory. That is page in cache. If yes, then page number has some page number. This is the logical bit number, and has a frame number given to frame number like 001011. That is like, this is the denoting the zero. If you understand about the binary numbers, that's denoting the 2 and it's denoting the 3, and that is the case. Yes, then TLB. TLB means translation. What? Translation look aside buffer, where it's going on the frame, where frame, that is your located by the physical address of the memory divided into two parts. So that is the first is frame, that is frame offset denoting by the bit, and second is the frame offset. Okay, it's going to the physical address, that is 0 to this. So this is your physical address. If no, in that case, if page in cache is no, then we have to go page table or page map table, that is 0 to 1, and giving the item to this TLB miss and storing the physical address. So this is the logical diagram, and it's going accordingly. We have understood about it. Advantages. The advantages of the pagings are it allows to store parts of single process in a non-contiguous fashion. It solves the problem of external fragmentation. Disadvantages. The disadvantages of pagings are it suffers from internal fragments. Yeah, definitely, because there is a no thing like we are just in fixed size storing more data, and because it's wasting the some memory and also utilizing the more memory, so that is thing. Okay, second, there is an overhead of maintaining a page table for each process, definitely, and the time taken to fetch the instruction increase since now two memory access are required. Okay, page table is a data structure, like data structure, and it maps the page number referenced by the CPU to the frame number where that page is stored. Okay, characteristics. Page table is stored in the main memory. Number of entries in page table equal to number of page in which the number is divided. This is the thing. If number of entity in a page table, number of entity in page table, so equal to number of pages in which the process is divided. So page table base register contain the base address of the page table, and each process has its own independent page table. Page table base register provide the base address of the page table, and the base address of the page table is added with the page number referenced by the CPU. Okay, it gives the, like, CPU will understand that was think like CPU page giving the bit number of that, and second is your offset. Okay, it gives the entry of the page table containing the frame number where the reference page is stored. Page table entry format, inside it page table entry format. This is okay. The page table entry contains several information about the page. The information contained in the page table entry varies from operating system to operating system. The most important information in a page table entry is frame number, present absent bit, and protection bit, reference bit, dirty bit, modified bit. Okay. Segmentation. Segmentation is also important fact in the operating system, and we have to understand also this very clearly. Segmentation is a memory management technique in which each job is divided into several segments of different sizes. Okay, one for each modules that contain pieces that perform related functions. Each segment is actually a different logical addresses space of the program. When a process is to be executed, its corresponding segmentation are loaded into non-contiguous memory, though every segment is loaded into contiguous block of available memory. Segmentation's memory management works very similar to paging, but here segmentation are variable length, whereas in the paging, pages are of the fixed size. The operating system maintains a segment map table for every process and a list of free memory blocks, along with segment numbers, their size, and corresponding memory location in main memory. For each segment, the table stores the starting address of the segment and the length of the segment. So, a reference to a memory location includes a value that identifies a segment and an offset. Segment table. Um, it maps two-dimensional logical address into one-dimensional physical address. Each table entry has base address, like it contains the starting physical address where the segments reside in memory. Limit is it specifies the length of segment. Okay. Now that is the segment 1. Segment 1, segment 2, segment 3 to till segment n. Okay. So there is a something like where is a process P, there is a segment 1. Table of segment map table is your 1 to till n, it's going the number, segment number. Size, how much size we are giving to these segment number, like size of the 400 for the one segment number, 200 for the second segment number, and 100 for the three segment number, and x for n. Okay. Then is like your memory address. We are giving some memory address inside it. It's depending on the size of the variable. Okay. Then it's taking the space into the main memory. That's your operating system definitely. So here is a something like where it's taking the space, like 100 is taking 100 and 200 is taking like there is a some think like 1 2 till 1 2 3 4. So 4 segment size means 1 2 3 4. 4 segment size means 1 2 3 4 till fifth. It will store after 4 definitely. Eighth where, like 100 we are using, that is the 100 is taking. So 100 is a memory address. Okay. So till this. So that is the thing, like we have to be initialize what is the reality of that. Okay. So translation of two-dimensional logical address to one-dimensional physical address. So this is diagram for CPU. CPU generally connected to paging number and second one paging offset. So paging number, that is bit number of your paging address. Paging offset means your word number of your paging address, piece, where logical address is giving to as that is limit and base address. Okay, that is just segment number. Okay, Limit and base address, like giving some limit how much time, how much memory is taking. That's going to on that condition if d means your offset is less than the limit. Yes. If no, that is error definitely. If yes, then we go to the fragment, that is offset d, and base address plus limit. So this is the thing where we have to use overthink and translate over data. So this is the very most important thing we have to understand about this. Okay. Address generated by CPU divided into two: segment number and segment offset. Again, segment number is the same bit required to represent segment. Segment offset means number of bits required to represent the size of segment. So what is the advantages of the segment we have to understand for this? Advantages, like segment table consume less space in comparison to page table in paging. Okay, so this is taking the less space. Disadvantages of segment, like a process are loaded and removed from memory. uh, like as a process load and remove from the memory, the free memory space and broken into little spaces, causing external fragments. Okay. Fragmentation, a process are loaded and removed from memory. The free memory space is broken into little space pieces. It happens after some time that process can't be allotted to memory blocks, considering their small size, and memory blocks remain unused. Okay, so this problem is known as a fragmentation. Fragmentation is a two type: external fragmentation and internal fragmentation. Total memory space is enough to satisfy a request or to reside a process in it, but it's not contiguous, so it can be used. Internal fragmentation, memory block assigned to process is bigger. Some portion of memory is left unused and it can't be. Memory block assigned to process is bigger. Some portion of memory is left unused as it can't be used by another process. This is the internal fragmentation. So for a page fault means a page fault occurs when a program attempts to access a block of memory that is not stored in physical memory or RAM. The fault notifies the operating system that it must locate the data in virtual memory. So then transfer it from the storage device such as HDD or SSD. So you think about like SSD, we generally calling to the laptop and where we are storing that. Just think about it and write in your copy like why we are using the SSD in our laptop. Okay, in any kind of thing. So to the system RAM. Page replacement algorithm. This is really important, and I'm giving you things you have to understand it. I'm not saying like you just understand, like if I have only this thing, I am just sharing these things with you because it's important. If multiple videos on the YouTubes and where you can easily read out from their side, but I have only for one thing. I really want to easy for you that you can easily summarize these topic. At least I'm just overviewing in front of you so that you can understand it and you can about the concept, like yes, these concept we have to understand, not even from my side, at least from any other side you can do this. I'm doing this only for your attraction to related these topic because it's really important and really helpful for doing the programming also. In any kind of thing, like whenever you're using your concept, any type of program languages, coding in front of you, can't expect this related to everything. So my thing is, I'm just making these videos for your convenience so that you can understand which type of topic we have to summarize for the future and for the interview purpose. So okay, so this is my side, and so start from the paging replacement algorithm. First in, first out, FIFO. So we understood in the data structure like what is the FIFO. FIFO means first in, first out, definitely. So it's using the queue. Okay, queue, queue. This is the simplest page replacement algorithm. In this algorithm, the operating system keep track of all pages in the memory in a queue. The oldest page is in the front of the queue. So let's see for this. So just consider of this, like your operating system keep track of all pages in the memory in a queue. So the oldest page is in the front of queue. Okay, when a page need to be replaced, page in the front of queue is selected for the removal. Okay, so consider page reference string 130356 with three page frame here. So we have to take three size, one, two. Just see my cursor, where I'm cursor. This 1, 2, 3 given to us. This is the frame, page frame. Find the number of page fault. So what's the technique of the first in, first out? That is your, we have to the oldest page in the front of queue. Okay, and we have to front of the queue to select to remove the oldest page. Which item in front of queue, that we have to select the removal. So I have to, first item is 1, so I am storing the 1. In the case of a storing side, we have to use miss, and if we are deleting, so okay, just understand from the beginning. First we are storing 1, that is miss. Second we are storing, because there is also a space, 3, that is miss. 0 is also miss, because it's different type, 1, 3 and 0. Okay, now I am to again 3, so 3 is here, yes, 3 is here, so I have no to store anything inside right now. So what is this hit? Because there is a same element, 3 is already stored in here and we do not need to again store in it. Okay, so there is a 3, so again 3 we write it, return it there, that is the hit again. So front means 1, this is the front size, so I have to do this. Oldest element, what was, that is 1, so we have to remove it 1 and we store the 5, so that is miss. Storing 6, which will remove 3, so this is miss. Hit means already same item present inside the list and you do not need to again address that, so that is your hit. Miss case is storing the element inside the list, so that is your miss case. So this is the thing. So and now you have to total page fault 1, 2, 3, 4, 5, 6. You have to count only miss condition, not to hit, because hit is already there. Hit element is already there because 3 is already there, so we do not need to count it. So we have to count only the miss character, that is miss, miss. So there is a 6 miss here, so that is total page fault is 6. Initially that is the language, if you are comfortable just use. So page fault, we can page fault ratio, like total page ratio is 7, so and page fault is 6, 6 by 7 is 0.85. Okay, optimal page replacement, second technique. This in this algorithm, pages are replaced which would not be used for the longest duration of the time in the future. This is very important. Which page will not be used for the longest duration of the time in the future? So there is a, okay, so we have to given these elements and we have to given 4 page frame. So now we have to given 4, like 1, 2, 3, 4, 4. So how we'll count it? Firstly we store the 7 inside it, so 7 I'll store it. Then 0, then 1. Also miss condition, inserting during the insertion we will use the miss. Again 2, there is a no 2, so we are using the 2. 0 again is coming, so there is a 0 already there, so we will hit position. And counting the 3, there is a not 3, but we are deleting which will not use further 7 is using, no, so we are deleting the 7 from here. Okay, लाइक आगे किसी एलिमेंट का यूज़ नहीं होगा, उस केस में क्या करेंगे अपन 7 को रिमूव कर दें, बिकॉज आगे क्या है, देर इज़ अ नो थिंग फॉर द 7 इन फर्दर रिक्वायरमेंट, so that is the thing we are deleting 7 from here. Okay, but now we are stored in 3. After that storing the 0 for hit, because 0 is already there, so we have to hit. Now 4 is already any, there is a no, so now we are deleting 1. Why? क्योंकि 1 जो है वो आगे यूज में नहीं आ रहा. In that case we are deleting 1 from here and we are storing the 4 in replacement of the 1. Okay, this is the miss condition. Hit means 2 is already there. Okay, so we are not deleting it. Hit up 3, up, like there is a no 3 before that, so we are stored. Do not store the 3 here because already it here. 0 again already here, so hit. 3 already here, hit. So these are hit conditions right now. So how many miss condition we have to count? Only miss, that is 1 2 3 4 5 and 6. So that is the page thing. Okay, last one is your least recently used, means in this algorithm page will be replaced which is least recently used. Okay, means we have to given these elements and fragments pages for. So I am storing the 7 here. Now miss and miss condition till to 2. Okay, now 0. 0th position is already 3. 7 list uses. Okay, previous case was that like no further use of that particular element, it is less uses for that, so we are using and deleting this 7 and storing the 0, so that is again same case. Hit 4 miss, so we have to delete 1. 2 hit again, 3 already, 0 already, 3 already, 2 already and 3 already here, so again page fault size is 6. So consider there is some case like this is the example, this is the question you have to write and you do by your own. Okay, this is another one questions you have to write and you do by your own. Okay, so this is all about your management of memory, and there's 3 techniques of that: leaf, FIFO, optimal search and least recently used. Both thrice are really important in operating system, so is in your hand for learn. I have just one idea to briefing the FIFA in front of you so that you can learn. I don't know where you will learn, but at least you should know about these topics. Yes, we have to cover these. Okay, so